So if we just pull the block slightly and release, what will be the time period of oscillation? So what we are supposed to do is, first of all, we'll assume that the
K
spring remains
equal
vertical all the time. So find the K equivalent. Yeah. So what is the K equivalent here?
So the 2K spring are and the K spring in the left are connected in series.
So these two are in series,
No, that
but these two are in
that's
parallel.
that's
They are in parallel. So this is 2K, K becomes K and K becomes parallel. So 2K and 2K and K becomes again 2K by 3. So K equivalent becomes. So you know how to take the parallel and series combination. I mean, doing
sir.
the
I thought
calculation.
2K by 3.
Okay. Then the T will be 2.2 M by K
2K by
equivalent. Uh, you can write as M by 2K by 3. So that's the answer. So, so of course this constant will be, I mean this will not come in any junction, but these are pretty easy. So we'll see some more rigorous questions which demand some sort of thinking. So let's say this is a question in which so there is a spring and this spring is attached to a support, and now we have a block. And on the other side, we have a different spring with support. So the block is not connected to the. This is too far. Okay. So you can see the block is neither connected to the K1 nor to the K2, and K1 sorry, K K2 are massless spring. If I release, if I displace slightly and release, what will be the time period of oscillation? That's the question. You can ignore the gap between the block and the spring, that's negligible. So whatever value you displace by, that will become the amplitude as.
So 2 pi root under M by K1 plus K2.
Are you sure? When the block will go on the right side, which spring will compress?
K2.
K2
What will be the role of K1 in that case?
full.
Full.
K1 is not attached, dude. K1 is not attached. K1 is
Achha.
nothing is connected. They are having support, so if you push, it will be pushed. That's it. So when you go on the right side, only K2 will be compressed. K1 will play no role actually. and while going towards left from the mean position, only K1 will play the role, K2 will do nothing. So in the one oscillation, the half journey will be with K2 and half will be with K1, and that's why you have to add the half time period with K2 and half with K1, and we have to add the value to get the total time period. Is this clear? Okay.
So that half time period, can you repeat again?
When the block will be, let's say you are pushing the block towards left, okay, or let's say you give some velocity to the block towards right. So you give a gentle, you can say a kick or the jerk to the block, and the block starts moving towards left or towards right, let's say, any direction. So block will compress the spring and will come back. On the other side, it would compress the K2 and will come back. This makes the one oscillation. So one oscillation is going here, coming back. So when you go from here to here and you come back, how much oscillation will complete with K2? Only half, isn't it?
Yes.
Because the moment you reach here, the K1 will leave you. I mean, K1 cannot go towards left. Then you compress the other block, it will compress and come back. So what you do is you only cover the half. So the total time period is T1 plus T2 by 2 by 2. Like, you can write like this. So the time period of the the first spring will be 2 pi under root m by K1, and T2 will be so the obvious answer is pi under root m by K1. Yes, 2 will cancel. Is this clear?
So I didn't understand why the right
Okay,
half.
first of all, yeah, okay, no problem. I understand. So let's try to understand what is the meaning of oscillation with the same example of spring block system. So first of all, I think you guys are not too, I mean, clear with what is the meaning of one oscillation. If the block is attached to the spring, so now if I, let's say, give some velocity, imagine it will go somewhere here, it will stop. This is the extreme position.
Yes, sir.
So going from mean to extreme is how much oscillation? Tell me.
T1.
If something goes from mean to extreme, how much oscillation complete?
1/4.
1/4. Very good. So coming from here to here, 1/4 extra. So going from mean to extreme and the coming back to mean is only half oscillation.
Yes, sir.
So until you're not going this direction, you cannot complete the oscillation.
Yes, understood.
So now if you look at this scenario, what do you think? The block is going from here to here, extreme, coming to the mean. How much oscillation?
Half of it.
Now, but while going towards left, you change the spring, isn't it?
Yes, sir.
And you again do the half oscillation with K1 also. So
Yes.
you come back to the same position and with the same direction of movement after making half oscillation with K1 and half with K2. Is this clear now?
Yes, sir. Understood.
Alright. No. Imagine this block is attached to the spring. But on the other side, we have another spring which is not attached to the block, but it is attached to some wall. Now, what will be the time period process? Done.
Sir, just simplifying, sir, one second.
So when you go towards the right, both string will come into action, right?
Sir, one second.
Sir, we have to minus the this of
Nothing, there is always plus. Yeah?
Sir, is it pi bracket m divided by root under m divided by k1 plus k2 plus 2 times m by k1 root under. 2 times that.
Why 2 times? It is again half only. So you go towards the right,
Sorry, half.
and then both the springs are in action. So the formula becomes this much. So your half journey is with both spring and the half journey is with only K1. Understood? Is this clear, guys?
Yes.
So you can just create a similar question like this. So what is difficult here is to realize that what is mean, what is extreme, and once you realize that it's pretty. So let's say we have a spring on one side, and other side we have the elastic thread, like a rubber band or something. So right now it is in the natural length, and it will also have some equivalent spring constant. So any thread, if it is elastic and if it can behave similar to the or follows the Hooke's law. So we are assuming that even the rubber will follow the Hooke's law and deformation and the force will be proportional and with the equivalent spring constant K2. So I hope this question is clear. Again, what is the time period?
Sir, is it 2 pi m root under K1 plus K2?
See, again, you guys are not doing the complete oscillation. So if you go, let's say this is the mean portion. Draw a diagram like this: mean, extreme, minus. So if you go, let's say like this. So when you go from the mean position towards right, only which spring will be into action? K1. Why? Because K2 will become loose, no? It's a spring. Sorry, it's the rubber band. So if you go towards right, you cannot compress the rubber band, isn't it? A rubber band will only
Elongate.
you can only elongate. You cannot compress. It will just become slack, elastic, or whatever you can say. So going towards the right, only K1 is in action. So it is pi multiplied by pi multiplied by under root of m by K1. That's it. But while going towards left, the rubber band will also pull you. So it in a way, the K effective becomes K1 plus K2. I can see that these are same ones. No? Is this clear?
Yes.
So this is again a new situation. So if I attach both sides, then it's a simple answer. You know the answer. So if we attach the spring on both sides, I mean to the block, then the answer is pretty much simple, and we all know the answer. Now, what will be the time period of oscillation? So you can see both journey, whether you go right or left, both spring will be involved, right? And they are in parallel. So answer will be, I hope you know the answer.
Yes. 2 pi m root K1 plus K2.
So what you need to understand is that a slight modification may confuse you. So you have to be very careful that what is happening. Okay. So look at the fourth example. You can see we have two distinct spring of spring constant K1 and K2, and there is a block. Now there is a sufficient gap, and I would like to mention the gap value. So the block has been given initial velocity V naught. What we are supposed to find is the time period of oscillation. Like oscillation here means you go right first, you compress, you decompress, you come back, you go left, you compress, you decompress, you come back. That makes one oscillation. It means the block should be moving in the same direction after one oscillation. So the whole idea is, if that is the case, then what is the oscillation period? Need not to be SHM, because in between we have non-SHM motion, just a motion, and then we have the spring force. Okay, so try this out. Tell me.
So can you explain the question again?
Question is, find the time period of oscillation of this block if it is given a velocity v naught as shown in the figure. Like how much time it will take to come back to the similar location in the same direction, moving in the same direction.
So I got disconnected. So L2 and L1 are its natural. Linkage.
Element is the gap. It's just a gap. It's a frictionless surface. You have a block, and distantly we have two springs kept on the two sides. So the block will move freely for a while. It will hit the spring system, will get compressed, will come back, then leave the spring, will move freely, and then again go to the left, will compress the spring, come back, leave the spring, and again come back to the same position. So what is the total time taken by the block to be at the place in the same, moving in the same direction? So that's called the oscillation period. Okay, you didn't answer. You come here, you compress, you come back, you come here. You go here, you compress, you come back, and then you come here. Wait, this is the one oscillation. Understood? What do you want one oscillation?
Yes, understood.
So if you understand the oscillation, then you can do this question.
Sir, is it 2
Hmm.
pi root under m by k2 plus 2 pi m root under k1 plus 2l1 plus 2l2 by v0?
See, you cannot complete the oscillation with the spring because spring can only support you halfway. See, the moment you hit the spring, that is the mean position. So you can go here and come back. You cannot go on the other side. So that it means you only complete the half oscillation. So here mean is here. No? So we have multiple mean. We have mean for the K2 here, mean for the K1 here. And you can see these two means are separated by a gap. Earlier, the mean was same for both. Do you realize this? No. Yes. Maybe. Do you realize the location of mean? We have two separate means here.
Yes, sir.
Every spring will have its own mean, huh? And they are not at the same position. So you have to think. See, the most important part which you are missing is you're not realizing the basic. What is the mean? What is the extreme? How to think about mean? How to think about the extreme? That is creating all the problem. You have to spend time. I mean, spend brain. I mean, try to understand what is exactly mean. What is happening? How you're interacting with each spring individually. So this answer is pretty much simple. I can add directly pi under root of m by k1 plus m by k2 for the spring portion, but we have one extra, which is the gap, and the gap is you travel 2 times L1 and 2 times L2 with a speed of v0. That's the answer.
Sir, I got this answer.
Very good. That's the correct answer. Is this clear?
Yes, sir.
Sir, but I didn't think like this way. Sir, I thought that the time required for
So,
from the origin to the K2 will be L2 by L1 by V0 and again
correct, correct.
returning to K.
Yeah. So I did all those things at once because yeah, this is what we'll get eventually. So you travel L1 2 times. You travel L2 2 times, and rest you play with the spring, right? Okay. So what is the third variety of question that you will come across? This is the second variety. Imagine we have a situation in which uh, we have a perfectly rigid rod. It's a rod. So of course you can compress and elongate as you wish. This rod is attached to a block. It is kind of welded together. A rod is welded together with block. Now, of course, you cannot move by large value because it's a rigid rod, maybe iron rod. But this will not stop from the concept of SHM because if you hit hard, it will vibrate very vigorously. You can experience it. So there will be,
So to and fro.
yeah, 12 okay. Because the rod is not perfectly rigid, it's an elastic rod, so it will have Young's modulus, area of cross section, length L, and I think that is sufficient. And the block of mass M. So of course that amplitude part you can't see much. Amplitude is like something like negligible, but SHM will be there and it will have time. So tell me what is time. I'm not putting anything on the right side, so it's welded together. So the rule is you need to find the K equivalent first, and that this is what we have done in the chapter of elasticity. If you remember, you can do it. Else, I will re-explain. Not an issue.
So 2 pi root under m by y.
Pardon?
2 pi root under m by y.
2 pi under root m by
Y.
y. Oh, God. Okay. So in case of spring, if you remember that the stress is defined as Young's modulus into elongation upon original length, right? So the elongation exactly will behave as x. Let's say x is the deformation. So f turns out to be how much? A y by L into x. And if you compare with the k equivalent formula, so this part I was expecting that you guys will figure it out. So the answer is this clear?
Yes.
So for a rod, the equivalent spring constant is A y by L, and yeah, you can say M L by A by. And that is why I told you, if you remember, I told you that spring constant is always inversely proportional to length. If you remember, and it's the proof. So although we derive from the elasticity concept, but this is true for any spring, and that is why when you cut a spring, the K and L product remains constant. So for every spring, the property which remains constant is the product of the K and L. It is clear?
Yes.
So now imagine a situation. So we have a spring of a spring constant K and there is a block. Let's say the natural length of the spring is L0. Now if I cut the spring into two halves and if I suspend the block with the one of the half, if the time period in the first case is T1 and the time period in the second case is T2, what is the relation between T1 and T2? So here the situation is spring is cut into two halves and block is suspended from the.
Sir, in T2, in denominator, under root 2k will come.
Yeah, right. So here, although the k is not given, but you can figure it out that because length has halved, the new k will be twice of the original, right?
Yes.
So the t1 will be 2 pi under root m by k. So the t2 becomes 2 pi under root m by 2k, and therefore you can say t1 is basically t2 by t2 is t1 by root 2, huh? Like this. So they may give you the time period of the first case, and they may expect that you can answer the time period of the second scenario. Is this clear?
Yes, sir.
Yes.
So far we have seen the spring in which the elongation is happening in one dimension along the spring. But now we'll see some more complex situation in which things will be happening in a different way. So the next problem will be like this. So once you practice, it's pretty easy, but in the very beginning you need to understand and figure it out, like what is happening exactly. So imagine instead of hanging the two string, parallel to each other, or maybe series of parallel, we hang something like this. So we keep the spring identical with symmetricity, because then only we can do the mathematical calculation. So both these spins are having a spring constant k, and it is suspended. You can assume the angle made by the spring as theta with horizontal, and at the connection you may attach some bead of some mass. That's easy, or you may attach a block also. So definitely the spring will be under elongation in the very beginning also, but whatever is happening in the very beginning, that we ignore, because gravity is balanced by the initial deformation. So what, how we need to think about? So first of all, we need to understand that gravity, which is mg, is already balanced by the deformation created in the spring, which we don't know. We don't see that. So of course, these springs are not in their natural length, but
So then,
you never need to worry. You never need to worry about the initial value, because whatever be the initial value, there that is being balanced. So gravity has done its role. Gravity is balanced. When you pull the spring slightly down, so when you pull the bead slightly down, a spring will elongate further from the initial deformation, and that extra elongation will only create the restoring force. So you need not to worry about gravity. Okay. So just think about the extra force. The question is, if I pull it slightly down, then what will be the time period of oscillation? So before you think of time period of oscillation, you have to do the simple calculation. You will pull by some small value y. Mathematically, you can think this is small value, and your next job is to find the net force, and then write the F equals to ma, find the acceleration, and then you can compare with the standard equation of a system, and you will get the answer. So can I try this for a while? Then I will help. Is the question clear? What I'm saying?
So please,
yes.
will you repeat?
So you need to pull by y value. So the y is small. Then you have to solve for the, I mean, find the net force, like the way you actually solve the system problem. Because this
Yes.
formula is not, these are not in parallel, so you cannot apply the formula which you have learned. Every time you come across something new, you have to do it from scratch. That's a rule.
Sir, is it pi root under 2m by divided by k sin theta?
No, definitely no. See, you have to think from the laws of motion perspective. Don't think of SHM. You go back to the chapter of laws of motion. Think about very basic. Okay, look at this. How to do this? So you need to do some geometry first. I will not do this thing. I just do this line. And now you're pulling it slightly down. So for the sake of writing, I will just do it bigger. Y is very small. It's almost negligible. So this is the situation. And this is theta given. That's fine. So if I draw a line like this, we can issue consider this as theta. That's not an issue. The reason is simple because y is very small. So the question is, what is the elongation in each spring? So you can draw a perpendicular like this. And this is theta, this is 91 theta, so this is theta. And if you draw a perpendicular from here to here, this is also theta. So you can see that we have been able to understand that and the theta part. And because I have taken y as the shift, downward shift, you can see clearly the elongation is only this much. This is the elongation because these two lengths are equal from here to there. So the change in length is this much, and that length is how much? You can see the elongation in the spring is audible.
Yes.
Yes, sir.
So elongation in the spring is basically y sine theta in each spring. Okay, so how much force will develop? The spring force will be how much? So they will pull like this. So both spring will be pulling like this. What is the spring force? K into x, which is ky sine theta. But what is the restoring force? Because they are acting in a different direction. So what is the net force or net restoring force? I can see clearly it's a 2 FSP. What? Cos or
Sine
sine?
theta.
Correct. It is 2 times ky sine theta into sine theta, isn't it? This is basically 2ky or 2k sine square theta into y. So if you want to only compare the k effective, then that's simple. The effective k value will be 2k sine theta, and therefore the question can be, I mean, this can be reduced to a single spring with a mass m with the value of k effective, and now you can solve, and you know the answer 2 point root m by
Okay.
k. So this is the answer. So this is of course a new variety for you guys. You
Sir, I
haven't
got
seen.
K effective as 2K sin theta. That's why
I,
I was getting 1 sin theta. Yes.
yes, this is a very common mistake that we,
Yeah, so I also took x is equal to y.
yeah.
So now I took x equal to y sin theta. I didn't consider 2 first.
So y is the vertical displacement, but the elongation is something different. No? Elongation in the spring is not y.
No, I got y sin theta only with elongation.
Very good. So you got half of it, and only half was, I mean, what you missed. So based on this concept, you will come across variety of problem. So I'll just solve one of them. Just you can try.
So can I show the previous page? Done.
So imagine a situation. So this is the like situation in a horizontal plane. So the diagram which I'm going to draw will be in the horizontal plane. Then only we can these things will be more meaningful to you. So imagine we have a two string. one, two. This is the mass, and then we have another set of springs attached below. Maybe we can just join like this. So this is, let's say, alpha, and but this is beta. Both are K1 and these two are K2 and K. So we keep symmetricity maintained. And what you do is you pull it like this and release. So what will be the time period? So things are symmetrical. I mean, although the diagram may be slightly disoriented, but you can assume everything is symmetrical. No?
So K1 is bigger or K2?
Pardon?
K1 is bigger or K2?
K1 is bigger. No, it doesn't matter. So you're only supposed to find the K effective and the rest will be easy for you.
So we will subtract the forces to find the.
No, see, I mean, if you pull it down, K1 will pull up and K2 will push up. So in a way, both will add up. No? Force is only going to add up. So this is similar to this problem.
So
You
not
remove
copy.
you remove the upper half by one spring and lower half by another. And you can see clearly that these two are in parallel, right? If you remember the block and two spring problem, and this will be 2K1 sine square alpha, and this will be 2K2.
Sine square beta.
And we know these two are in parallel because in between we have a block. So the K effective will be the sum of two. I hope you understand.
Yeah, got this one.
Pardon?
Children got this.
Okay. So the time period will be simple 2.2 m by K effective. Rest you can do. Okay. So it is also possible that they may attach multiple springs in like various direction. In that case, you have to do the vector addition. So if the motion happens, if you are not able to figure it out what is going to happen, then you have to actually use the vector notation, okay, to solve the question. So I'll show you one vector problem, which is very difficult for any beginner. But it's pretty easy if you just apply the laws of motion in vector form. Okay, let me just check the problem. So that is from Olympiad examination. So here is the problem. What, what I'll do is I'll just this. Yeah, you can check the question in WhatsApp. It's a big question, so I cannot write. So you're supposed to solve the first part, uh, and the only idea is that you have to just find the net force as a vector equation. And once you get the relation, which is like F equals to vector equals to some something into R vector or something. So this is like a equation of SHM. So this is again omega square. So you have to just do this same in the vector form, and once you do it, you will be able to get the answer. So you can try this out. You can take 10 minutes. That's not an issue. But this will give you one different perspective of how to attempt question of SHM even in vector notation. So read this question out and let me know. Okay. Am I audible?
Yes.
You got the question? Can you see the question in WhatsApp?
Yes.
Okay.
Yes, sir.
Right.
So can I solve this?
So only PC will be elongated, no? Hello, sir.
Am I audible to you now, guys?
Yes, sir.
Here, imagine this bead is at the center, and these are at 120 degree each other. As per the question, if you displace somewhere else, some random location, which are not vector, so now the bead has come here. So now, how you're going to write it down? Okay. So every spring will try to go back to the mean position, and we need to find the elongation. So you can name it point P, and then now you can write the BP length. So what is the force by the first spring? By the spring A. One. So the spring formula, if you remember the spring force formula, it's minus K into deformation. That's a vector notation. So you can write as F1 equals to minus k, and if we talk about the delta r, the elongation part. So elongation part is how much? Can we write OA? AP. So I want to know what is AP. So you can write as OA vector plus AP vector equals to R naught vector, right? So the AP turns out to be R naught minus OA. Similarly, the BP will be, you can write similarly R naught minus OB, and the last one is C is minus OC. Yes. So F1, okay, let me remove this part. You can write that. So the net restoring force will be minus K1, sorry, KCM minus K AP plus K BP plus KC. Is this clear? So the string was unstretched, so you have stretched towards the point P. So spring will apply the force towards itself. So this is the force. And if you substitute the value, what you get? 3R naught minus OA plus OB plus OC. So this is the net force. And if you look carefully, OA plus OB plus OC is how much? In the very beginning, it was at rest. The three vector will, because these are symmetrically placed, so the sum of the three vector will be 0 from vector notation. If you know. This is null vector, right? And therefore, the answer is minus 3kr. So this is simple answer. And if you compare with the standard equation of SHM, which is omega square r naught, let's compare. So what you get? Omega square to 3, and this is this is the force. My bad. This is the force value, so you can write as acceleration as minus 3k by mass of the beam into r. Now, when the ring will also have mass, then it becomes two mass problem. So since uh, assume ring as fixed, I'll do this problem separately when the ring is also able to move. Assume ring is fixed. So this case will be minus omega square r naught. You can write like this, and then you can say time period is 2 pi m by 3. This is the answer. Now, if you look at the problem as per this problem, the answer will be different. So what they will give you the answer is 2 pi and so they'll give you the reduced mass eta by 1 plus eta into m by 3. The when the ring is free to move. But we'll learn this later on. This is the reduced mass concept.
Sir, block.
Pardon? So this is the question. This is the answer. If you solve the When ring is free, we will come to later on about this. If the ring is fixed, then your answer is this one. This is how we approach.
So why we took that zero here?
Why we took the?
Zero plus sum of OA vector plus OB vector plus C.
See, the rubber bands are like zero length. Huh? So what is the new length of rubber band? AP. New length is BP. New length is CP.
Yes, sir.
So how much spring force will be there? Spring force is KAP. And
Yes, sir.
spring force will act towards the A. No? So it is in opposite of AP. So minus KAP, minus KBP, minus KCP. Isn't it?
Yes, sir. Understood.
Yeah. So force always acts opposite to the reformation. And that is why this is the answer. And if you proceed, you will get the answer. So anyway, this slightly. So what we can do next is can you go to the two block level? Just let me check. Okay, fine. So now we can come to the concept of two block problem. So now situation has changed. Now instead of one spring and one block, if we have seen that we have fixed the spring at one end, but now we want to like to take a very different set of problem in which we have two blocks. And these two blocks are attached to a spring, and they have different masses m1. So if I move the one of the block and release, if you compress the spring and release, both block will oscillate, right? So no matter what is their masses, both will reach the mean position at the same time. Both will reach the extreme position at the same time. It is not possible that one will be moving, other will be at rest. So both will reach the respective minima and maxima at the same time. So how to solve question like this when we have both masses which are capable of moving because the spring is not constant, not fixed. So it's easy to solve because uh, time is frame independent quantity. So you can choose any frame in which the motion looks simpler. Here, if you look from the ground frame, how many blocks will move? One or two?
Two.
Now, what frame one must choose so that only one block will move?
So block frame.
Correct, block frame. So you can choose either M1 or M2. So if you choose M1, then M2 will be moving only. And if you choose M2, then only M1 will be moving. And that will reduce the problem to one block problem, which you can solve. But what is the modification we need to implement doing so? So the moment we choose one of the block, then it becomes a non-inertial frame of reference because it is also accelerating. So you need to add the pseudo force apart from the regular force and then solve the question the way you want. So what I will suggest is the method of solving is I assume that the spring is compressed or elongated. So let's say imagine a scenario in the next scenario. you can just assume that let's say the blocks are now elongated, or you can assume compressed. That's not an issue. And M1 elongation. So you can choose one of them as a frame of reference, find the net force on the other block, and then do the SHM using the basic the approach which you have already learned in the last lecture, how to solve question of SHM. So now you are going to solve the question of SHM in the non-inertial frame, and therefore you have to use the pseudo force apart from the actual force acting on the block. So try this out, then I'll help. Okay, you must try something. Think about it. Question is clear? Hmm? Hello guys, is this clear?
Yes, sir.
Okay. Okay, go ahead. The moment you assume one of the block as a frame, you can think that as a wall, and then you have only one spring and one block to deal with. The only difference is the net force will change because you are in a non-inertial frame. Is this clear?
Yes.
Yes, sir.
Sir, is it 2 pi root under m by 2k?
No. So what did you tell
Acha,
me?
m1, m2, okay.
What no? What did you tell me? What you did?
So this one. So it will be 2 pi root under m2 by k.
Yeah, tell me.
2 pi
Tell me
root under
again.
m2 by k.
2 pi under root m1
Sir, m2 by k.
like this.
Hmm.
So I got M1, M2 by M1 plus M2 into
A.
yes.
Very good. This is excellent answer. And this is the right answer. And this is very much known to you. It's a reduced mass, right?
Yes, so yes.
It is like the mass. We just need to replace the mass by reduced mass, and everything looks okay. So whenever we have two mass problem, what we do is we replace the mass by reduced mass. So it is as good as thinking like we have a wall, we have a spring, and attached to the a block of mass. And what is mu here? Product of the mass upon summation, right? If you remember the reduced mass concept.
So,
Right? Now, how to solve this? Let's say if you have solved using any one of, if I choose M1 as the wall, so this is like a wall. And now if you look, because it's a, first of all, understand if X is the elongation, this will try to move this way, this will try to move this way, right? This will go with accession A1, this will go with accession A2. What is A1? It's the net force upon mass we are doing in ground frame.
yes, Bama. Yes, sir.
The next part is drawing the ability of this M2 in the M1 frame. So it will experience Kx, and because A1 M1 is going towards the right with axis and A1, so it will experience pseudo force M2 A1. So the net force will appear as Kx plus M2 A1, and we can add this as equals to M2 A2, or you can say A2 dash, not A2. This will be a relative acceleration because this is the frame, no? So we call it A relative. Okay, so this is how we can write, and then you just need to substitute the value. Let me solve it here. We have space somewhere, so I can write here. So Kx plus M2 A1 is how much? Kx by M1, right? And this equals to M2 into A21. So I can take Kx common, and this becomes M1 plus M2 upon M1 M2 equals to A21. So A21 terms are to be K by mu into X. Why minus n is not there? Because I haven't written. So if you want, you can write, because this is a positive deformation. So you can make the modification, but it really doesn't matter. You understand why it is so. So you can compare with the formula. Now X itself is the relative separation because it is not the displacement of individual block. What is X? A relative separation between the block. So this formula is the you can rewrite like this, and you can just compare. You can see, and so your answer is, this is like something standard. Everyone remembers this. So maybe first time you have to solve, but next time you can just, okay, you know that it's two block problem, which you can reduce into one block problem by uh, doing something like this. Is this clear?
Yes.
So replace the two block by one block of value equals to the reduced mass. Huh? All right. So long time back, Jay asked one question, which is pretty easy. You can solve mentally in one line, but it was like 10 marks problem. I don't know why. 10 or maybe 5, 6 marks at least. So there is a round pipe,
It's advanced.
advanced, long when it was subjective question. So there are two beads of mass m and let's say 2m, and it is attached to a spring like this. But there are two springs, one on the upper side, of the other is on the. So the spring constant here is, let's say k. This is, let's say, 2k. So what is the time period of oscillation if you simply do whatever, displace whatever? So here the question is very simple. We have two mass problem along with two spring which are in parallel. So you have to reduce the mass into the reduced mass and also spring into k equivalent, and then you can get the answer in one line. So answer is simple: mu by k effective, and that's it. You can solve in 5 seconds. This was a, like maybe 5 marks problem. 5 marks in 5 seconds. So do you realize that it's a 2 block problem? So that is difficult. The most difficult part is realizing that it's a problem based on this concept. That is the challenging part. But once you realize, it's easy. Understood?
Yes.
So since it is directly connected to the spring, both
Correct.
the
Sir, 2 pi rokna hai 2m by 9k.
Yeah, correct. Because the k equivalent is 3k, no?
3k.
Very good. It is not difficult. I mean, if you realize, once you realize, things are very easy. So k effective is 3k, and the reduced mass is 2m by 3. Yeah? So the
Yes.
t will be 2 pi under root 2m by 3 into 3k, which is 2m by 9k under root. Sorry, 2 pi I missed as usual. I'm not right. So I hope this is clear. I hope this is not so difficult. So we have seen almost 90% variety of problem of spring and the block problem. Everything we have seen from spring block situation. But there is the next league of problem will be even more difficult than this. Okay, so now let's go into the a different difficulty level of spring block problem. For that, I need to take some question. And where can I take the question? Let me check somewhere. Okay. Yeah. No. So let me send you the question first. Okay, so I have sent you some question which you can see, and these 4 variety question we have to solve. And to our surprise, this question can be solved almost mentally. So we'll come to that. So let me take some other variety of. Okay. So okay, again there is one more problem. Am I audible to you guys?
Yes.
So there is a block of really large size, as you can see. And this 2 block problem can be asked in a variety of ways. So you have to just figure it out that okay, this is the 2 block problem. So realizing that it's a 2 block problem is challenging. The rest is easy. So let's say it's a big, maybe a deck of a cruise. Just imagine kept on frictionless water, floating in a water, and let's say water do not offer any resistance whatsoever. And we have another block kept like this, which is again attached to, and the support is attached to the bigger block. which is in turn kept on a frictionless surface. So if I displace the upper block slightly right or left, what will be the time period of oscillation? Can you think about this? Am I audible to you?
Yes.
So try solving this question. Okay, do one thing. Don't solve using formula. Solve from the scratch. The rule is assume the block is displaced by x with respect to the block and then solve. So I want the scratch solving, like not the formula. Solve it from scratch.
Sir, but how will the bigger block will affect the problem?
Pardon? Pardon?
How will the bigger block will affect the problem?
See, the bigger block is kept on a frictional surface. So if you move the block right or left upper block, the spring force will move the lower block, the bigger block. You can draw the MBD separately for the big block and small block. Then you will realize. Else you can't realize. So do it first. First you do it, then you will realize.
So now after writing FBD for both the blocks and writing equation, then what do you do?
So after drawing the ABD, choose one of the block as the reference. No? That is how we solve. So you first choose the block and take its acceleration as the frame of acceleration, and then acceleration of frame, and then apply the pseudo force on the remaining block. Okay, so that is how we solve. No? If you remember.
Huh.
So it's the same process. You have to realize the process and then solve it. If I give you the solution, then you will never learn this concept. So that's what I'm saying. You attempt, get stuck, try to come out of this obstacle, then realize what exactly we are doing here. So we are solving question in a frame which is non-inertial, right? Why we are doing this? Because we are comfortable with one block and one spring. We are not comfortable with two block and uh, uh, so can you do it now?
Yes.
Okay, try this out.
Sir, got the answer. Hello.
Yeah, tell me what is the answer?
Time period or omega?
Yeah, time period
Time period 2 pi
2 pi.
root under m small m capital M divided by m plus m into k1 plus k2.
And that's the right answer. Very good. So you did it using the formula or
Sir,
just
no,
that?
the FBD.
ABD. Then that's absolutely awesome. Okay. So this is how you can attempt any problem. And if you look at this answer, you can realize that okay, this is exactly mu by k equivalent, right?
Sir, but I have one doubt.
Yeah.
That acceleration is equal to minus omega square x, right? But I
No,
am
no,
not getting a
no,
negative
no,
sign
no,
on the
no, no,
left
no,
side.
no. Minus is the direction which we choose in the very beginning. So if we are writing the magnitude, so if I'm not writing the minus, it means I'm just writing the value. Okay, so that will never affect the answer. Don't worry about it. So generally we write, if we know the value only, we write only value. So we are writing net force equals to mass into acceleration. So because we are writing in the I mean, like just a value, so we won't get the negative answer. Okay. So if you want, you can put in negative sign in the very beginning, but that really doesn't matter. Okay. So this is it. So you can solve like a question like this as well. So now, do you realize the previous problem? This problem. This is exactly same answer. If ring will also have mass, let's say mass of the ring is given as eta times mass of the bead. So capital M is small eta into small m, and therefore the reduced mass will be how much? M by m plus m, and this will give you this answer. This is what I had written earlier, and the rest is same thing. Because the k equivalent we got as because this is the like k equivalent, so you can just call it as this implies k equivalent is pk. And once you get the k equivalent, you don't solve anything. You can just write as uh, the time period equals to 2 pi under root mu by k equivalent. So that was the whole idea of solving this question. Okay. It is clear.
Yes.
The first step was to find the equivalent spin constant. The other step is to solve. So that's why this question is challenging because it involves two concepts. One is first of all the difficulties writing in vector form, because that is something which we don't practice at all. But I have given you one problem, so you can have at least this practice. Okay. So now I have shared a variety of problems. You can see it's like some picture on the board, which is when I used to teach in classroom, which I stopped for almost 2.5 years. So those are the questions which we'll attempt now. So I'll take those questions.
So your voice is not audible.
Hello, hello. Am I audible, guys?
Yes.
Okay. So how to think about solving this question? So how many spring do you see?
2.
Okay, that's good. So now you know we have two spring. Very good. And how many oscillating body we have?
2.
The oscillating
If
body
pulley
is,
is not marked.
yeah, if pulley is massless, then we can say it is only the block, right? Of course, pulley will be also there, but I will keep consider only block. Okay. So here the oscillating body is the oscillating not body, oscillating mass is M, right? The block, correct? Pulley is mass. It is clear so far? All right. Next step. So right now there must be some tension force, isn't it? So if I consider the
So,
tension, yes. Tell me. So right now there must be some tension, no? Because gravity is pulling the block and it is stationary. So it means there is a tension everywhere.
Yes, sir.
So what is the tension in the lower spring? It must be gravity. Because if you draw the FBD of the block, you can see mg is acting downward and tension is acting upward, and that is why it is balanced. So you can say tension in the lower spring is exactly equals to gravity. Is this clear?
Yes.
Now, if the tension we know that the same tensile will be available throughout the string. So the spring force will exactly be equal to the tension developed. Understood? So if I say T naught with the initial tension, I'm just trying to show you something more detailed. So if I draw the FBD, then T naught is equals to mg. But this is not the only case. In fact, this is also equals to K2 X2 because I don't know what is the elongation. Let's call it K2 X2 naught, like initial elongation is X2 naught. And yeah. What about the upper spring? What is the tension there? So the upper spring will have tension 2T naught if you look at the pulley, right? So for this pulley, the downward pull is 2T naught. If you remember the
Yes.
laws of motion. So tension in the upper spring will be 2T naught, and this must be equals to K1 into X1 naught. So these are some initial elongation, initial tension, initial value, and all these things are initially available. Now we never start with the initial value because we know that initially everything is balanced. So what we look for is the extra deformation and extra force which are developed over this value. So we will just ignore this part. So let's say this part I don't, and this is done. Let me draw this diagram once again. So what I have shown you is the initial value. If you want to know that okay, if there is some value in the beginning also. So after this step, what we do is because we have two string. So first of all, let's say I'll assume that the block is pulled down by x. So when you pull the block by down by x, what do you expect? The K2 will further may elongate by some new value x2. X2 I'm assuming the extra value, the net elongation. And let's call x1 is the elongation in the upper spring. Okay. So the next question is, can we relate the x1, x2, and x? Because that is the most difficult step. Can we relate these things? I mean,
Yes. So we can
x2
use work energy power.
work energy power. Okay, yeah. That is that method, na? The work energy. Yes, you can use it. Definitely.
Hello, sir. Hello, sir. Sir, your voice is not audible.
Hello, hello. Am I audible?
No.
If the K1 will elongate by x1, how much block will go down? Assuming other things are not moving. X2 is not there. So if the upper spring will elongate by x1, the pulley will also come down
Two
by x1.
times.
So it will become 2 times x1, right?
Yes, sir.
Now imagine x1 is fixed. If x2 is the elongation in the spring of spring constant K2, so if spring will elongate by x2, how much block will come down?
2x1 plus x2.
Exactly. So this is the formula. You can do it by other method also, but this is
Sir, can you
easy.
explain this again?
Yeah. So if the pulley comes down with C, if this will elongate by x1, the pulley will come here. It will release this much extra rope to for the block to go down, right? So this is 2x. Yeah. But if only this will elongate, this is let's say fixed. Pulley is fixed. I mean the K1 is not changing. If x2 will elongate, so this will elongate by x2, this will go down by x2 only. Then.
Yes.
So one will only give you. So I can say the net movement of the block is twice of x1 plus x2. And I hope you rest you know the relation, the constant relation. T1, x1, T2, x2. This is how we solve. Okay. So for this pulley, if you draw the ABD, pulley is going down with x1. This is elongating. This is elongation in the first is uh, this side of the x2. X. This is going down. This is elongated. Elongation. Okay. So x plus minus. Okay, anyway, this is better is from this one. Or you can do by T1, x1, T2, x2, the formula which you know from the laws of motion. Now, this is the part. The first part of solving questions like this is writing the relation between various elongation and the motion of the block. So once you do this, the next step is simple. What is the tension in the spring? So let's say the extra, see T naught is a tension. So we assume the new tension is T naught plus some value. So what we draw is only the new value, the extra value. So let's say the tension developed is here is T. And we never represent the gravity. Why? Because gravity is balanced by the T naught itself. So any extra tension will be the net force for the block. Okay. Is this clear?
Yes.
Yes, sir. So if this is T, so you can add T equals to K2 X2 and 2T equals to K1 X1, right? This is you can understand this.
Yes.
So we can now write X equals to 2x1, which is 2T by K1, and x2 is T by K2. Okay. So this is how we get the relation between uh, T we can take common. It is 4 by K1 plus 1 by K. Okay. So we got the tension versus, and now if you write the laws of motion for block, the only thing you can see that it's going downward, but force is upward. So it's
Call from India.
retardation basically.
4478947.
So the Newton's laws of motion for block, if you write it, so you can see clearly that it will create the retardation. So the acceleration will be minus g by m for the obvious reason. That's it. And the t itself is how much? X by 4 by k1 plus 1 by k2. So the acceleration turns out to be minus 1 upon m into 4 by k1 plus 1 by k2 into x. So this entire thing is basically your omega square, right? Yes. See, I just wrote the minus from my side. When if I don't write, doesn't matter. So now you can see that we got the omega. So what is the omega? Have you space? Yes, I'm writing here. Omega is under root. This is answer. So the time period is how much? 2 pi omega, which will be like this is answer. Do you realize this? If you have realized this, then do one thing. Again, solve the same problem without looking at the answer,
Yes,
and
sir.
then solve one of the problems which I have given you already from the scratch. Then I'll give you the trick at the end of this.
Yes,
So at
I
the
have
end,
one doubt.
yes, tell me.
So that x will be equal to x2 minus 2x1.
X goes to
x2 minus
x1.
2x1.
No, all will elongate. No, everything is elongation. If the upper spring will elongate, the block will go down with 2x1. If a lower will elongate, elongation, I'm stretching it, no? So block will go down only, no? Isn't it? So both
So
will
no,
support
because the
the.
t minus tx1 is equal to tx2 and
No. This is not how you can write. This is not how you can write. Uh, the way of writing is different. So if you look at the pulley one, how to say this? The pulley will experience one tension here, which is 2T, and here it is T, here it is T. Okay, and the way of writing is that this point, if I just draw this point, let me draw the end point. So the 2T is acting upward, but the point, the red dot in the topmost point, I mean, let's change that color of dot. Yellow dot, blue dot, and red dot. Tell me how the red dot is moving downward, and how the tension is acting on the red dot upward, right? So tension on the red dot is acting upward, it's going downward, so it is minus T into X. We don't see the arrow, we just see the motion of each dot. Okay, you can just let me go inside. Maybe this will help. Just do the three strings up, and just do the three dots at every end. One dot, two dot, three dot. And we represent the force. So the tension on the blue dot will act like this. Tension on the red dot will act like this, and yellow dot will act like this. Yeah, I'm not sure. how the blue dot is moving and the yellow dot. Red dot.
I'm not understanding the red dot. It will act upward, right?
The
Tension.
red dot. The red dot. The tension on the, we see I'm cutting from here. So how the red dot will explain the force downward? Hmm? Can you see this now?
Oh, yes.
So
So
it
what
will
will I?
come from left side and x1 from right side. So total it will be 2x1 plus x2.
Yeah, so you can see 2t and x1 are same maximum. So 2t x1 plus t x2 minus tx equals to 0. And if you solve, you get the same
So
answer.
this is the work method.
Yeah, correct. This is the work method. Is clear?
Yes.
All right. So rest you will try. I mean, I'm giving you rest as homework. And there's one more variety which I would like to discuss, but that will be in the next lecture. And yeah, maximum effort we have to put for this question. The rest questions are very easy. So you can start solving from the sheet which I have shared. So have I shared the sheet
So now
from
what the
President? Pardon? You can solve any spring block problem. Any means any. Any doubt?
No.
No, sir.
Fine. Bye and take care.
My
Bye, sir.